Thank you for coming to my talk about what is coming up after the Pectra upgrade. I thought that this title was a bit catchier, figuring out fusaka, but for anyone who is not familiar with the term fusaka, that is the upgrade after Pectra. So what is coming up after Pectra? It's fusaka. Fusaka is probably a term that you're going to hear a lot around the topic of Ethereum protocol development and governance over the next probably year as developers are working on shipping fusaka. In the talk today, what I'm going to talk about is what is going into the fusaka upgrade, what code changes are being prioritized in fusaka, as well as the timeline for fusaka. But before we get into that, this is a little bit of an announcement because very recently developers set the mainnet date for Pectra. Pectra is the next immediate upgrade that is going to go live on Ethereum May 7th, 2025. It is less than a month away now. Developers are they're still working on the final client releases for Pectra, but that should be released later this week or early next, and the official Ethereum Foundation blog post announcing the Pectra upgrade and all of the final client releases should be out by next Wednesday. So please take note of this. If you are a Ethereum node operator, you will need to upgrade your software by May 7th in order to stay connected and part of the Ethereum blockchain. So yes, small little shout out for Pectra. If you want to know more about Pectra and the code changes that have been prioritized in Pectra, I did give a talk on what's going into Pectra for DevCon last last November. So if you're interested in that, you can find that talk online. But as I said earlier, this is a presentation not about Pectra, but what's coming after Pectra, fusaka. So let's dive into the very many code changes that developers are prioritizing for fusaka. I will note that the scoping discussions for fusaka are still quite intense, and many code changes are being debated. However, the one code change, if there's anything that you take away from this presentation, the one code change that you should know is of highest priority in fusaka is that first one up there, PeerDAS, EIP 7594. It is a networking protocol that allows consensus layer nodes to perform data availability sampling on blobs. Now, another more non-technical way to talk about PeerDAS is that it's going to greatly scale Ethereum's data availability capacity, greatly scale the ability for Ethereum to support scaling through layer 2 rollups. Rollups post data to Ethereum, and right now the dedicated block space that Ethereum has for that kind of data is limited, is the best way to put it. The data that, the block space that is reserved for layer 2 rollups and other people that want to post large amounts of data to Ethereum, these are called blobs. And as of the Denkun upgrade, which is the most recent Ethereum upgrade that went live, I think, last March, there is a target of about 3 blobs per block on Ethereum. With the Pectra upgrade that's going live on May 7th, Ethereum developers are going to double that capacity to 6 blobs. And now with PeerDAS, the idea is to increase blob capacity by multiples more. Now, developers are just testing out PeerDAS design in its early phases with very conservative increases. So the one that they're testing with right now is just 12 blobs per slot, 12 blobs per block. But theoretically, the maximum that developers are trying to reach is 50 blobs per block. That's a huge scaling increase. And all consensus layer client teams, developers, even though they disagree about so much with this upgrade, as we'll talk about, the one thing that everybody agrees is that PeerDAS should ship as soon as possible. So I just cannot stress enough that the headliner for fusaka is PeerDAS. And what developers are prioritizing in PeerDAS, in fusaka, is the rollup-centric roadmap for Ethereum. So if there's any roll-up teams out there, know that developers are really trying to ship upgrades that service you guys as much as possible in the next upgrade after Pectra. Now, you will notice that there are some acronyms in the highlighted section, SFI and CFI. SFI stands for Scheduled for Inclusion, and that means developers are currently implementing that code change for fusaka. The vast majority of EIPs that I'm going to talk about in this presentation are CFI'd. CFI stands for Considered for Inclusion. That means developers haven't yet started working on that code change, but are considering to start implementing it into Fusaka once the SFI'd EIPs are stable and have been implemented on a Fusaka DevNet. There are only 2 EIPs that have been SFI'd, which means there are only 2 EIPs that developers are working on in earnest for Fusaka. One of them is PeerDAS. The other one is EOF, which we'll get into in a couple slides. But I've organized this presentation by bundling the EIPs by what they do. And so in this slide, we're talking about the blob capacity increase code changes. And the first one is PeerDAS. The other one is EIP 7892. This one is a mechanism to automatically increase Ethereum's blob capacity over time. These are automated hard forks that gradually increase Ethereum's scalability as a data availability layer. And one of the arguments for it in Fusaka is with PeerDAS, there's so much anticipation for how much more scalable Ethereum could become as a DA layer with something like PeerDAS. But there is concerns that perhaps Ethereum as a data availability layer will not be able to scale immediately to say like 50 blobs per block. So the idea of EIP 7892, blob parameter only hard forks, is to introduce a gradual mechanism so that developers can more safely introduce blob capacity increases. So if they find, they can start off with say 12 blobs per block, which is very conservative, increase it again in like 6 months or maybe a month by 1 blob or 2 blobs. The schedule is not set. However, this could be a way for developers to be able to reach higher levels of blob throughput without too much concern about the safety of the network, and with being able to do adequate testing as the network starts to grow its DA scale. So that's EIP 7892. It is a CFI'd EIP, so developers have not said that they're going to, they haven't started working on implementing it for Fusaka, but it has been strongly argued for, because if PeerDAS goes live, then there's a question of how much developers will be able to increase the scale of DA, how much they'll be able to increase the number of blobs, and this would be a mechanism to say, oh, you know, we'll try and reach up to 50, like reach that theoretical maximum, but do it in a gradual way, so they can test the network as that happens. The one thing I will note about this is it will require additional testing efforts and may prolong the timeline for Fusaka, because never before have developers done automated hard forks on the protocol. So there will have to be testing around, you know, how do we shut off this automation if necessary? You know, if we don't want to do the next automated increase, like how are we going to turn that off? And again, they'll have to decide about the schedule. In the essence of time, I'm going to keep moving and try and move a little bit faster. So the other set of code changes that developers are strongly considering for inclusion into Fusaka are blob base fee market changes. So this is basically, both of these EIPs try and make price discovery for blobs more efficient and faster. There are 2 ways that developers may go about doing this. The first way is considered to be the more complex way. It introduces a new variable for pricing blobs, and that new variable is just regular transactions. It's execution layer transactions, blob carrying transactions, because there are also transactions that happen on the consensus layer that price blobs on Ethereum. Alternatively, though, from that EIP, you can simply just increase the minimum base fee, the minimum cost of blobs on Ethereum. Right now, the cost is 0. It is virtually 0 for blobs. So if you want to make price discovery for blobs faster, you could simply raise that lower threshold. It is the simpler way to go about doing things, but there are concerns, maybe not concerns, but there are desires to go about introducing changes to the blob fee market in a more heavily researched manner. And so there's some developers that have a preference for the first EIP, EIP 7918, saying that it seems less. I think one of the developers said the vibes are good on the first EIP 7918 on the developer call. Anyways, so these both are considered for inclusion in Fusaka. Only one will be approved, though. So you can, yeah, the developers didn't know which one that they prefer, so they actually just CFI'd both of them. This is one EIP that is designed to help the operation and the adoption of based rollups on Ethereum. Based rollups are rollups that rely on Ethereum not just for data ability, not just for posting data, but also for transaction sequencing. And I'm not going to go into the technicalities of this EIP, but I will note there was a really great conversation about it on the latest consensus layer developer call, which I did a write-up for. So if you're interested in learning more about how this helps based rollups and the voices that were in favor for it, there are some pretty prominent voices like Ethereum Foundation researcher Justin Drake, a Sigma Prime developer which I think is Lighthouse, one of the client developers that were arguing strongly in favor for this EIP as it could greatly enhance the adoption of based rollups on Ethereum. But anyways, that write-up is on my Substack, which I'm going to link to at the end of the presentation. But we got to keep moving because I'm already like halfway through my time. But as you can see from the last 3 slides, a lot of these changes are, again, to support Ethereum's rollup-centric roadmap, right? So much of what developers are considering for Fusaka is for the benefit of Ethereum being able to scale through layer 2s, being able to scale through alternative protocols that are posting data back to Ethereum. It's not really focused on like Ethereum, it's scaling Ethereum itself, but we're going to get into that. So I mentioned earlier in this presentation that there's only two SFI'd EIPs. First one is PeerDAST. The second one is EOF. So while developers are focusing on this primarily consensus layer focused change, there are efforts to enhance the execution layer of Ethereum. EIP 7692 is the only other code change that developers are actively implementing for Fusaka right now. And what EIP 7692 does is it majorly overhauls and upgrades the Ethereum virtual machine, the execution environment of Ethereum. It will make smart contract code execution on Ethereum a lot more efficient and predictable and safer. This is a really big effort that developers have been working on for several years now. And even though I talk about it like one EIP, it's actually a bundle of 12 EIPs. And developers may still include a few more EIPs into that bundle if they have time. But yes, that is the other major code change that has been confirmed for Fusaka. There are a couple other EIPs that developers are considering for inclusion into Fusaka after they've implemented EOF and PeerDAST, and those are the bottom 2 over here. These are other code changes that would help the smart contract developer experience. I'm gonna, for the essence of time, keep moving. These 3 EIPs are also considered for inclusion, and this one is about scaling the Ethereum L1. So the code changes that developers are working on for Fusaka right now, again, prioritize the rollup-centric roadmap and also an improvement to the smart contract developer experience through EOF. There is, though, a strong segment of the Ethereum developer community that really wants to see Ethereum L1 scale along with Ethereum's L2 ecosystem. So alongside scaling the L2s and helping the L2 ecosystem flourish and grow, there's efforts to try and make Ethereum base layer more performant. And these 3 EIPs are all about doing that. So as you can see, many competing interests and priorities at play. There is a potential that these EIPs could be included in the later down the road for the Fusaka upgrade. So yeah, I'm gonna keep moving. These are a couple of other initiatives that do not have EIPs associated with, do not have specific EIP numbers quite yet. The first one, finalizing ETH 69, that is the next version of the Ethereum Wire protocol. It's a messaging protocol. It dictates how Ethereum nodes communicate with one another. And this is closely tied with history expiry efforts. History expiry efforts don't require hard fork. Developers are trying to coordinate that upgrade to the networking layer of Ethereum shortly after Petra goes live. However, one of the things that they would like to do in order to do history expiry, which I really don't have time to go into, but history expiry at a very broad level will allow nodes to drop significant amounts of data, which will be really good for making Ethereum nodes smaller, require less performant hardware and computational resources to run, because they're not going to have to store the entire history, the transaction and block data of the entire blockchain. But anyways, E69 is a version of the Ethereum wire protocol that will allow a node to be able to communicate, hey, that data you're requesting for me, it's already expired. You know, you have to go to another protocol to find out or to get that data, like the Portal network. That initiative doesn't have an EIP, but it's something developers have said they want to do by the time Fusaka goes live on Ethereum mainnet. There's a couple of other initiatives that developers were sharing that they would like to do for PeerDAS. One of them is limiting the number of blobs per transaction, and a couple of other improvements that client teams, very specific client teams were talking about they need to adjust in order to be able to safely raise the Ethereum block gas limit. So the prior slide, we were talking about the EIPs that would change aspects of the Ethereum protocol that would support a block gas limit raise. This third point is also about raising the Ethereum block gas limit, but it focuses on changes to the performance of clients to make client software simply more performant, to be able to handle more transactions, the processing of more transactions in a block. So yes, there's a bunch of other initiatives. This list is likely to get longer. All of the EIPs that I shared, for the EIPs that are focused more on the execution layer of Ethereum, developers did say that they've kind of closed the door on how many CFI, considered for inclusion EIPs, there can be for that list. However, the upcoming call, this Thursday, it's happening, the All-Core Developers Consensus Layer call, they're going to talk about what other consensus layer-focused EIPs should be CFI'd, and hopefully move forward there with a static, like no more changing list of CFI'd EIPs to move forward with, and then try and make that list even smaller over time. However, I imagine that as developers are moving through the implementation of PeerDAS, the implementation of EOF, I think we're going to see some decisions reversed and going back and forth. It's not usually a straight line to mainnet, which brings me to the final part of my presentation, the timeline. I'll talk a little bit about the process and why, you know, I personally think that the goal that developers have to try and ship Fusaka to Ethereum mainnet by the end of the year is quite ambitious and not likely, and why I expect there to be quite a bit more changes to the CFI'd list for Fusaka, as well as the SFI'd list for Fusaka. But in context for this timeline and why I'm kind of, you know, wary about whether developers will be able to do this is because of, well, one reason, maybe not the only reason, one reason is that Ethereum developers have recently approved a standardized process for shipping upgrades to Ethereum mainnet. And this was born out of the rather difficult process that developers had trying to ship Pectra to mainnet. At every single public testnet upgrade that developers had in lead up to Pectra, something went wrong. Something went terribly wrong with the testnet. And in light of this, developers wanted to ensure that there is a standard level of security and a standard level of boxes being checked off before developers feel confident enough to ship code changes to Ethereum. And this makes sense because Ethereum is a multi-billion-dollar technology. It's a multi-billion-dollar protocol, and you don't want to just ship upgrades willy-nilly that could potentially break Ethereum. So there's quite a few checklists for the Ethereum protocol upgrade process. I've only highlighted really just a couple for the purposes of talking about the process for Fusaka. Now, some of these really specify, you know, from the final client release date to the first public testnet upgrade, there needs to be a 30-day period. There needs to be at least 2 public testnet upgrades before Ethereum mainnet gets upgraded, and those public testnet upgrades have to be at least 14 days apart from each other. And there's a couple other bullet points on this slide that I'm not going to get into because now I only have 30 seconds left. It dictates like these days, like these periods. So if you map those days out and really try and visualize how could the fusaka process go, you're gonna need at least 2.5 to 3 months from when developers have finalized their implementations for fusaka and when they want to see it on mainnet. Like the final set of testing will take at least 2.5 months to 3 months. And so working backwards, really the most ideal way you can think about fusaka is they're gonna test EOF and PeerDAS separately for the next couple months, merge them together on a single DevNet. Hopefully by the end of the summer, all of that is good to go. Start adding in EIPs from the CFI list over fall and test those. And then in the winter, really try and make the final finishing touches to the fusaka upgrade. I personally think this is an ideal timeline, and it's still very early stages in the fusaka scoping discussion, so take it with a grain of salt, but this goes to show just some of the high-level targets that they're going to have to meet. Thank you guys so much for listening to this talk on what's going into fusaka. I hope it was helpful. There's a website link to my Substack. I cover Ethereum protocol development and governance every single week, so if you're interested in getting more details, please subscribe. Thank you.